Hi everyone. The first problem that I am going to discuss today from thermal science topic. The problem is consider incompressible laminar flow of a constant property Newtonian fluid. This is very important line. Constant property Newtonian fluid in an isothermal circular tube. The flow is steady with fully developed temperature velocity profile. The Nusselt number of this flow depends upon. So guys, Nusselt number is asked. Nusselt number in a fully developed flow, right? Fully developed temperature and velocity profile in a laminar flow. So this question is asked, my dear. That this depends on what Reynolds number, Prandtl number, both Reynolds number and Prandtl number. Reynolds Prandtl number, but not the Reynolds number. So guys, the right answer for this is your neither Reynolds number nor Prandtl number, because you know for laminar flow it does not depend on uh, Reynolds or Prandtl number, but for turbulent flow it is going to be depend on these numbers. Okay, so this is very easy. You have remembered the points in heat and mass transfer lecture. So this is 1 marks very easy problem. So I hope this is okay. Next problem. Next is the velocity profile. Given, consider a laterally insulated rod of length L, constant thermal conductivity. Assume one dimensional heat conduction in the rod. Okay, one dimensional heat conduction in the rod. Steady state temperature profile. One dimensional it is written. So guys, we know very well for one dimensional heat conduction. You know very well the relation. Suppose this is the rod. Okay, this is the rod, and this is your insulated. Okay, and one dimensional profile is there. Heat is transferred from this way, and it is coming out in this way. So therefore, for one dimensional, you know very well there is no heat generation in this. Therefore, d2 T by del x square, this is going to be your 0. If you do the integration, so after integration, dt by dx is equals to constant term का 0 का ये हो जाएगा constant. So again, if you do integration, it is going to be your temperature is equals to C1x plus C2. Temperature is equal to C1x plus C2. This is the right answer. So therefore, linear graph, it is a linear graph. Y is equals to mx plus c. Therefore, the right answer is A and B. A and B is the right answer for this. Okay, I hope this is clear. Very easy. Straight line graph we are getting in terms of temperature and x. Right. So it can be decreasing and it may be increasing, but the slope is constant. This is the very important. Next, counterflow heat exchanger, my dear. Very easy problem. Again, see, in a counterflow heat exchanger, inlet temperatures of two fluid, 1 and 2 are being this inlet temperature. So let me draw the profile. Suppose counterflow heat exchanger, the profile you know very well. It is going to like this. Okay. So in counterflow, the direction is opposite. So suppose this is the fluid 1, this is the fluid 2. So this temperature is your temperature inlet T2. T2 inlet temperature of T2 is 350. Okay. And T1 in is your 300. And specific heat is given, effectiveness is given. No problem. So guys, in this, we have to find out the actual heat transfer. With the help of effectiveness, we can calculate. So first of all, what we are going to do, C is given, C1. C1 is your 1000 and CT is your 400. So this value is your C minimum. So C minimum is very important here. So for effectiveness, we know very well. This is your Q actual, right? Actual heat transfer that we have to calculate it upon minimum Q max. So maximum is your C minimum into temperature, maximum temperature gap. So TH1 minus TC. मतलब hot का जो highest temperature, cold का minimum temperature. So this is going to be, guys, the effectiveness we have, that is 0.5. Q actual we can calculate from there. C minimum is your 400. Temperature difference is your 350 minus 300 into 0.5. So this when we solve 50 means 200 into means लगभग and 10,000. It is going to be your 10,000 kilowatt. Means it is your 10 kilowatt. This is the right answer, 10 kilowatt. I hope it is okay. 10 kilowatt is the right answer for this. This is the right answer. Match your answer, everyone. Next question. Again, it is a very beautiful problem, guys. See, a cylindrical rod of length h and diameter d is placed inside a cube of side length L. S denote the inner surface area of the cube. No problem. Means we have a cube and in which a cylinder is placed. First of all, let me make a cube. This is a cube. ये हमारा एक क्यूब है और इसमें एक सिलेंडर को प्लेस करेंगे, राइट, लाइक दिस. ये हमारा इस तरह का. अब इसमें एक सिलेंडर को डाल दो. इट इज गोइंग टू बी लाइक दिस. ये हमारा एक सिलेंडर, इसका डायमीटर d है और हाइट इसका h. क्लियर. और इसका जो डायमेंशन है ये l. These are the dimensions which we have given and we have to find out the shape factor. We know very well how to find out the shape factor here in this. So we are going to apply the reciprocity theorem. So it is going to be very easy. So this I am going to consider this as 1. This cylinder I am assuming as 1 and this cube as 2. So for reciprocity theorem, if we are going to apply reciprocity theorem, Reciprocity theorem is very simple. A1 F12 is equals to A2 F21. Correct? A1 and F12, since it is the cylinder is inside the cube, therefore F12 is 1. Therefore A1 into 1 is equals to A2 F21. We have to find out the shape factor F21. So this is quite simple. Right, F21 is nothing but F21 is your A1 by A2. A1 area is, we know very well, A1 area. So therefore A1 area here, curved area, this area is a pi dh plus pi dh, right, plus pi dh plus pi by 4 d square, pi by 4 d square. These two areas are there, two circles and one curved area, which is going to be your, you may write pi dh plus 2 into pi by 4 d square. Okay, it is going to be your pi dh plus pi by 2 d square. And A2 is nothing but 6L square. What is that? 6L square. 6L square because the cube area we know surface area is 6L square. But we have to find out the shape factor of FSS. Right, shape factor FSS means the shape factor of cube with respect to cube. Matlab F22 we have to find out. Actually, it is typing error. It should be written like this. FSS, the shape factor of cube with respect to cube. F22, for F22 we know very well. We know this F21 plus F22 is equals to 1. Therefore, F22 is equals to 1 minus F21. Therefore, 1 minus A1 by A2 means pi dh plus pi by 2 d square divided by 6L square. So this is the right answer. If you match the answer, you are going to get. The correct answer is option number D is the right answer. Okay. I hope it is clear. Very simple problem. Just apply the reciprocity theorem, you will get the answer. Next question. Biot number. Again, very easy. What is asked in this? See, a very large metallic plate of thickness K, thermal conductivity K, is cooled by air stream. T infinity is this with the heat transfer. This the central line is temperature is Tp. Which of the following can be cases can be lumped parameter model to study the heat transfer in the plate. Lumped parameter model, guys. So for lumped parameter model, first we have to calculate characteristics length LC. Okay. So let me draw the diagram. If we draw the diagram, it is given your D and it will be like this. Okay. This is the actual diagram. So now this length you have, that is L, and this is your D. Okay. So first of all, characteristics length LC, characteristics length, that is V by area, volume by area. So volume is very simple, that is L into D, because this dimension is your L and this dimension is also your L. L into D divided by area. Area is your L into L, right, plus L into L. This is your total surface area. So once you solve, this is LC is going to be your D by 2. Correct. This is your characteristics. This is your LC. Once you got the LC, now you can calculate the Biot number. So guys, lumped heat analysis is used when Biot number is less than 0.1. Whenever Biot number you will get less than 0.1, then only that option will be correct. So now calculate the Biot number for each case. So for case 1, option number 1, since we know the Biot number is equals to HLC by Q. It should be 0. Less than 0.1. Option A now match. Biot number in this case will be H. We have guys H is your 10, LC by K. LC we have calculated and this is your 100. So H into 0.5 divided by 100 into 100. 100 into 1000. Right. 100 into 1000. Clear? Because the D we have, D value is 1 mm. So 1 mm we can calculate, D is your 1 mm means 10 to the power minus 3 meter. So once you put this value, you are going to get. So we have calculated, and this we are going to get less than 0. Right. So A is correct. A is correct. And again, similarly, if you calculate for H, for option number B, for B, if you are going to calculate by your number, it is going to be your 100 into 0.5 by 100. So it is greater than. Right. So it is your greater than 0.1, therefore it is not satisfied. Similarly, C, if you are going to calculate 100 into 0.5 divided by 1000 into 1000, it is very bigger value. It is your less than 0.1, it is your correct. Therefore, similarly, if you calculate in the last one, since in the last one the value is 1, take a value, yeah, 1. So it is also not satisfied, very higher value. Therefore, the right answer is A and C. So remember that, guys, in this problem for lumped heat analysis, you have to calculate the Biot number, and if the value of Biot number is less than 0.1, so then lumped heat analysis is satisfied. I hope it is okay. Thermal size problem we have done. Thank you for joining me and keep watching.